estimation. Problem. Glaucoma involves increased fluid pressure inside the eye due to the inadequate fluid flow between cornea and iris. This will damage the optic nerve and causes progressive and irreversible loss of vision. Healthy eye. Light rays enter the eye through the cornea, pupil and lens. The optic nerve head is placed direct opposite to the lens. Then clear liquid aqueous humor circulates inside the front portion of the eye. To maintain a healthy level of pressure eye within the eye, a small amount of aqueous humor is produced constantly, while an equal amount flows out the eye through a microscopic drainage system. Glaucoma. Disease of the optic nerve. When damage to the optic nerve fiber occurs, blind spots usually go undetected until optic nerve is significantly damaged. Leading cause of blindness all over the world, especially for the older people. Risk factors. It will affect due to age, family history, poor distance, and eye injury. Objective. Our objective is to develop an automated technique to analyze the fundus images of the eye and to calculate the optic cup to disc ratio. This is a normal eye. This is early glaucoma. This is advanced glaucoma. In advanced glaucoma, cup size is increased. Steps in the proposed scheme. Region of interest calculation, disc segmentation, disc boundary smoothing, cup segmentation, boundary smoothing, glaucoma diagnosis. Coming to the block diagram, we have to first analyze the retinal image, then select the region of interest and optic cup detection, disc detection, and measure the disc height and to measure the cup height, then to calculate the cup to disc ratio. Region of interest selection. To reduce the computational component requirements by only focusing on the appropriate region. Here we have this appropriate region. Disc segmentation. For the disc segmentation, thresholding is a technique in image processing used for binarization. We selected the threshold value as 230. This shows a segmented disc. Here we use direct least square fitting algorithm. This will be explained in our program. Disc boundary smoothing. These all will be explained in the program after that. Conclusion. Okay, then we'll see the program. In our project, we have three programs. One main program, second one is ellipse fitting, third one is ellipse. First, you have to go for the main program. First, we have to select a file and path. File and means path n. It means it will get the file from the specific path. It will only get the images with the format like JPG and BMP. I equal to im read path n file, and this will store the image to the eye. Then we resizing the image to 256 into 256 size. Then it will show the image. Then region of interest is calculated. Then we have selected some blank page to compare the original image and blank image. Then from that we can get the segmented disc. As far as we have selected the threshold value as 230, if the pixel value is greater than 230, I3 value will be 1. If it is less than 230, I3 value will be 0. From that we segmented the disc value by multiplying the original image with the segmented dilated image. Here we have the dilated image. Here we multiplying the dilated image with the original image. Then we can get the segmented disc. Likewise, we are segmenting the cup region from the disc region. Here also we are setting the threshold value through 30. If pixel value is greater than 230, it will be I6 value will be 1, or less than 230 means it will be 0. This is the segmented cup value. Then by using conventional Hull ellipse fitting, we split the cup and disc with the two regions. One is ellipse fitting, the another one is ellipse. Here we calling the ellipse fitting program. By calling it, we ellipse fitting. Ellipse is nothing but we taking 6 constant values x. For k equal to 1 is to max k, if length of x naught will be equal to 1 means x position is equal to x naught, y position is equal to y naught. Radius of m is equal to RA of k, radius of n is equal to RB of k. If length angle is equal to 1 means angle is equal to A and G. Then we go to the main program. Here we calculate that the cup height h1 and the disc height h. Then we have to calculate the cup to disc ratio, which is the ratio of cup height and disc height, which is shown in the last equation. Then we have to run the program. First you have to save it, then run it. We get 7 different type of images. We can also make it as a 50 or 100 also. We're making some simple things in program. First is the region of interest image. From the region of interest, we are calculating the black and white image. Which is the brightest was is a disc, optic nerve, disc or optic nerve head. These are the fibers. Disc only have the fiber nerves. The cup won't have it. As we told, we generated a dark image to compare the black and white image and the disc image. By comparing these two images, if the pixel value is greater than 230, we can get the same. We can get that pixel in that image by multiplying these two images. If the pixel value is less than 230, it will show the dark side, which means black. If the greater than 230, it will show the brightest part, which means white. Then the segmented disc, we have to separate that segment cup. For that we have used the same value as the 230. How we choosing the cup value means the optic cup will never have a fiber nerve, so it is easy to find the cup region. Figure 6 will show the boundary of the cup and disc. The light portion here are the boundary of the cup, and the dark portion here is the boundary of the disc. We have to smooth it by ellipse fitting and ellipse smoothing. This is shown in here. This portion is the optic cup portion, and this is the disc portion. This is ellipse fitting, this is ellipse. This is for the cup segmentation, this is for disc segmentation. At last we have to find the cup to disc ratio. Advantages of our proposed project: reduce the processing time and improve processing consistency for each patient's fundus image. This technique increases efficiency and reduces the cost. Prevention from loss of vision. Conclusion: this algorithm computes optic cup and disc ratio, which is used to measure the presence and severity of glaucoma. Our success rate is approximately 97.2%. Okay, thank you.